Welcome to the Explainer. You know, every major discovery in social science, whether we're talking about understanding voting behavior or trying to predict crime hotspots, really starts with just one thing: data. But before you can find that amazing story hidden in the numbers, you've got to learn its language. So today, we're going to open up the Social Scientist Toolkit and do exactly that.
And that's because data really does have a language all its own. If we misunderstand it, we risk getting absolutely everything wrong. It's the difference between building your research on a solid foundation of evidence or on a shaky one that's just, well, bound to collapse. So imagine you're an explorer, right? And you're trying to navigate this vast, huge sea of information. How do you find your way? Well, data analysis is your compass. It's the set of tools that guides you through all the noise to find reliable answers, whether you're trying to chart voting patterns or map out crime rates. Okay, so the very first thing our compass tells us is that the world of data is basically split in two. Every single piece of information you will ever work with, ever, belongs to one of two fundamental types. And knowing the difference between them, it's everything. So over on the left, we've got quantitative data. This is anything that can be counted or measured. Just think numbers: the age of an offender, the dollars spent on a political campaign, that kind of thing. Then on the right, you have qualitative data. This stuff describes qualities or characteristics, basically sorting things into groups, like a person's marital status or the specific type of crime that was committed.
Let's start by opening up that quantitative toolkit.
Now, it's all about numbers, for sure, but not all numbers are created equal. We've got to make some really important distinctions here. First up, we have continuous data. This is anything you measure on a scale, where the values can be broken down into smaller and smaller pieces. Think about temperature, height, or, if you're a political scientist, the exact percentage of voter turnout in a specific precinct. Take body fat percentage, for example. It isn't just 23 or 24%, right? It could be 23.9 or 23.91 or even 23.912. That nearly limitless precision is the classic sign of continuous data, and it makes it incredibly rich with information.
The other type of quantitative data is called discrete. This is all about counting whole items, things that just can't be broken down. So in criminology, an offender might have 2 or 3 prior convictions, but they can never have 2.5. These are always whole numbers, and they represent a solid, indivisible count. All right, let's switch gears and look at the qualitative toolkit. What in the world do we do when our data isn't a measurement or a count, but just a label or a category? Well, this is where we use categorical data. It's all about sorting things into distinct buckets. For a political scientist, that could be party affiliation: Democrat, Republican, Independent. For a criminologist, maybe it's the type of crime: theft, assault, burglary. The key thing to remember here is that there's no natural order or ranking to these groups. Now, sometimes our categories do have a logical order. We call this ordinal data. Think of a survey where you're asked to rate your satisfaction from very poor to very good. We all know good is better than neutral. But, and this part is absolutely critical, we don't know if the gap between them is the same as the gap between, say, poor and very poor. The order matters, but the distance between the steps is a mystery. This chart visualizes that exact point. You can see the ranked order, that clear progression from negative to positive. And while that ranking is super useful, we have to remember not to treat these labels like they're precise, equally spaced numbers. They're more like steps on a ladder, where the rungs might not be evenly spaced at all. And finally, we have the simplest of them all: binary data. It can only have 2 values. That's it. It's a simple yes or no, on or off. Did a person vote? Guilty or not guilty? Pass or fail? It is the most basic form of categorical data you can get, with just 2 options. Okay, so we filled our toolkit with all these different data types, but how do we lay them out so we can actually start our analysis? Well, that's where data structure comes in, and thankfully it follows a really clean universal logic. In pretty much any analysis you'll ever do, your data will look just like this table. Each column is a variable. See, we have crime_type, which is categorical, offender_age, which is continuous, and prior convictions, which is discrete. And then each row is a single observation, in this case, one single crime. This simple grid is the foundation for everything. This brings us to what is, honestly, the most important question of all. Why have we been so careful to define all these different data types? Why does any of this matter? The answer is really the key to all good research:
Let me put it another way. Why is it a fatal mistake for a researcher to confuse data that comes from measurements with data that just comes from putting things in groups? Here is why it's so critical. Your data type dictates your entire analysis. It determines which statistical tools you can use, which graphs you can create, and ultimately what conclusions you're even allowed to draw. It's like the master key that unlocks everything else. Just think about it for a second. You can't calculate the average type of crime, can you? That makes no sense. And as you can see here, each data type has specific charts and analyses that are appropriate for it. Using the wrong tool for your data doesn't just create a confusing chart, it produces completely meaningless results that can totally invalidate your research. So in the end, this is way more than just a set of rules to memorize. Truly understanding the nature of your data, well, that's the bedrock of all valid discovery. It's the fundamental skill that separates flimsy anecdotes from hard evidence, and it's what ensures that the stories we pull from data are actually true. So, now you have the basic toolkit, and the next time you read a news story or you hear a policy debate, just ask yourself, what kind of data are they using? Is it the right kind for the question they're asking? Because all around us, in every social trend and every headline, there are stories just waiting to be told if we just know which tools to use to unlock them.